Hello, my name is Gurgen. I'm a systems engineer at NI Yerevan, and I would like to present you 77 GHz vehicle radar test system from National Instruments. Let's start from the system setup first. Here we have the radar sensor. The red dot that you see blinking on the sensor comes from the laser rangefinder for proper EIRP power measurements. As you can see, the sensor is currently mounted on the rotating table that can do both horizontal and vertical rotations for azimuth and elevation. And here we have rudimentary anechoic chamber that we use for these measurements. This is the system itself, consisting of two parts. So millimeter wave transceiver for 77 GHz, as well as the baseband part with the VST inside of it. The same set of hardware can be used for both signal analysis and for target generation. Let's jump into the signal analysis portion first off. And the first example that I'm going to show you is the antenna radiation pattern measurement. Here you can see the horizontal beam of this particular sensor and the vertical beam. This is the power measurement of this sensor, and we can see that the EIRP is around 40 dBms. And this is the occupied bandwidth measurement. And from the spectrum, we can see that this sensor transmits three different types of signal. One is the large deviation FMCW chirp. There is another small deviation FMCW chirp, and there are two CW tones inside the signal. And for further analysis, we can go and demodulate the signal and analyze the chirps and measure the chirp period, deviation, as well as the chirp linearity. Now let's go into the target simulation capability of our system. So this software is provided by the sensor manufacturer. And now I will introduce two targets. One is at 50 meters and another at 70 meters. And you will be able to see two targets on this interface. And these numbers will show the 50 meters and 70 meters targets on the sensor measurements. So these are two fully independent targets in terms of radar cross-section, range, and velocity. Now I can move the first target closer to the second one, and you can observe how the target moves on the plan view. And I can move the second target closer to the first one and bypass it. So finally I want to show you the close-in capability of our target simulation system. And I will introduce a target at 5 meters. We can see the 5 meter target on the display. And I will start decreasing the range by 1 meter. Now it's 4 meters, 3 meters, and 2 meters. And also, our system has range resolution of 0.1 meters. So I can simulate 1.9 meters, 1.8, 1.7, 1.6, 1.5, 1.4, 1.3, and 1.2 meter targets. So the range for this system is from 1 meter to 250 meters and above, with the resolution step of 0.1 meter. Thank you.